How are you all doing today? I hope you are doing great. We thank God for giving us another opportunity to learn. Now I'll continue to urge you to study hard and also to remember your seniors who are preparing for their final external exams, that is the BEC. So when you go on your knees, please remember them and also remember management as well as the teachers. Now today we are continuing with our topic machines, and I'm very glad that today being the last topic or last subtopic under the topic machines. I'm very glad, and I'll urge you to stay focused so that by the end of the lesson you should be able to achieve all our objectives for the day's lesson, and that is you should be able to perform or continue with the calculations under machines. You know, in our previous lessons, we were able to look at some calculations under machines. We were able to look at the work done, power, and energy that involve in machines or under machines. Now we'll continue with another calculation under machines, and therefore you should be able to perform these calculations. That is, you should be able to calculate mechanical advantage, velocity ratio, and efficiency of a machine. And two, you should be able to outline some effects of machines. And thirdly or lastly, you should be able to state reasons machines are maintained or serviced periodically. You should be able to state reasons machines are maintained or serviced periodically. So this is our objective for the day's lesson, and I'll continue to urge you to stay focused so that you can understand this particular aspect of our learning for today. Now let's quickly consider this question here. Let's consider this question. It said in a machine, a force of 100 Newton moves through a distance of 20 meters in order to lift a load of 250 newtons through a distance of 5 meters. We have to calculate I, the mechanical advantage of the machine, and 2, we have to calculate the velocity ratio, and 3, we have to calculate for the efficiency of the machine. The question again, in a machine, a force of 100 Newton moves through a distance of 20 meters in order to lift a load of 250 newtons through a distance of 5 meters. You have to calculate the mechanical advantage involved, the velocity ratio involved in this activity, and also the efficiency of the machine. This is a calculation question under machines. Now before we continue with the calculations, let's look at another aspect of today's lesson, and that is effect of machines. Let's quickly talk about the effects of machines. When we say effect of machines, we are talking about the good things that machines can help human beings in order to make the work more easier. So we are talking about effect of machines. So one, or the first effect, is that machines make tough jobs seem easier. If you have a very challenging work to perform or to do, with machines you can make the work more easier. For example, if you want to dig a trench, with the use of the excavators or machines, caterpillar, you can dig within the shortest period as compared to the manual method of digging or creating the hole. So machines make tough jobs seem easier. And 2, machines save time as well. If you are using machines such as washing machine to wash your clothes, You can see that the machine, you just pack everything inside with your water and with your soap. You on your machine, and within some few minutes or hours, your clothes can be ready for you. So machines save time. And two, machines save labor. Labor here, we are talking about the person involved in performing the work. That is the labor or laborers. So machines save labor. Here you don't need to hire people or to call people to work for you and pay them. You only use your machine to perform that particular work. And that doesn't mean that when you have a work that you need to involve people in order to pay them, you are not supposed to do that, or you shouldn't do that. Another effect of machines is that machines save cost. Here we are talking about the money aspect involved in performing a particular work. If you have machines, they can help you save cost. And the last effect of machines is that machines save energy. You will not use your energy to do such work. Assuming the work is very tough or very difficult, you will not use your energy. It's the machine that will perform the work for you, and therefore, the effect of machines, you can see that it's really good. Now let's also look at some reasons machines are maintained or serviced periodically. In our previous lessons, we saw ways of maintaining machines. But today we are looking at reasons machines are maintained or serviced periodically. One, as machines are being used, changes in the atmosphere or atmospheric conditions, example pressure in the atmosphere and the temperature, causes wear and tear of the various moving parts of the machine, and hence the need to carry out maintenance on such machines. Again, as the machines are being used to work, changes in the atmospheric conditions such as pressure, temperature. Temperature here we are referring to how hot or cold the weather is. You can see that these conditions causes wear and tear of the various moving parts of the machine, and hence the need to carry out maintenance in order for the machines to last. So one reason for maintaining or to service machines periodically is this. Now let's look at another reason. Because of friction between moving parts of machines, there's a need to lubricate them periodically. Lubricate here or lubrication is applying grease, which is like oil, to the moving part so that the part can move freely to reduce friction. So, because of friction between moving parts of machines, there is a need to lubricate them periodically. And that is another reason machines are maintained or serviced periodically. And we also have the third reason, which is machines in use vibrates or shakes a lot. Therefore, bolts and nuts become very loose, and some metal parts develop cracks, and hence the need to service them. I'm sure when daddy or mommy want to move or want to start his or her car, he or she normally checks the bolts and nuts, especially in the tires, so that to make sure that the tires doesn't remove whilst the car is in motion. And this is what the reasons for maintaining or servicing machines periodically. I hope you are taking notes. Now let's come back to our question. let's look at our question here. How we can calculate the mechanical advantage, velocity ratio, and the efficiency of the machine. So let's come out with your data. Quickly do that for me. So when you are given a questions or calculations under science, we write our data or the key information in the question. Now, what are they looking for, or what is the examiner looking for in this particular question? One, the examiner is looking for mechanical advantage. That is MA in short. And in our previous lesson, I gave you the formula for calculating the mechanical advantage. Now, let's look at some formulas here as well. We have the efficiency of a machine being equal to the work output over work input times 100%. Then the same efficiency can be expressed mathematically as load times distance load moves divided by the effort times the distance effort moves. And work output is also given as load times the distance load moves. Work input is equal to effort times the distance effort moves. And the same efficiency is expressed as mechanical advantage over the velocity ratio times 100%. And we also have the velocity ratio being equal to the distance moved by the effort over the distance moved by the load. So let's quickly look at our question here. Mechanical advantage is equal to the load over the effort. And we also have the velocity ratio, or we have to find the velocity ratio, which is also giving us the distance moved by effort. Distance moved by effort divided by the distance moved by the load. Okay. And the last, which is the efficiency, we can express efficiency of a machine as the mechanical advantage over the velocity ratio times 100%. Because we have been given the mechanical advantage, or we have to find the mechanical advantage, we have to calculate for the velocity ratio. Therefore, when we are done with this, we can use it to find the efficiency of the machine. Now, we are given some information in the question. We are given a force of 100 newtons. That is the effort, or the force is equal to 100 newtons. We also have the effort distance as 20 meters. Again, the load given in the question was 250 newtons. 250 newtons. So this is the effort or the force. So the force is 100 newtons, the effort distance is 20 meters, and the load is 250 newtons, and the load distance is given as 5 meters. You know, remember to add your units. So this is what we have in the question. That's the data. Now, to start with the mechanical advantage, which is I. MA is equal to load over effort. And this, the load is given as 250 newtons, and the effort or the force, which is 100 newtons. And the units cancel out, therefore mechanical advantage has no unit. So over here we have 250 divided by 100, and this gives 2.5 as the mechanical advantage. This goes here 1 and goes here 2.5. So this is the mechanical advantage. Now let's look at the second one, which is the velocity ratio, and this is also equal to the distance moved by the effort. So what is the effort distance? The effort distance is equal to 20 meters divided by the distance moved by the load, which is the load distance here, and that is what, 5 meters. And this also, the unit cancelled out, and therefore velocity ratio has no unit, and this is equal to 5 here, 5 into 20, we have 4 as our answer. So that is for the velocity ratio. Now let's look at the final one, which is the efficiency of the machine. So over here, efficiency of a machine is giving us the mechanical advantage over the velocity ratio times 100%. Because efficiency is how efficient or how good a machine can deliver or can work. So efficiency from the mechanical advantage, we have 2.5 divided by the velocity ratio, which is 4 times 100%. Remember to bring your percentage sign. And this gives, when you calculate this, it gives us 62.5%. Now we are good at mathematics, and therefore you can manipulate this simple mathematics or simple questions here. 4 goes into 100 how many times? 25 times. Then multiply it by 2.5, which gives 62.5%. So this is our efficiency for the machine. It means that the machine can work well. So, lovely learners, we've come to the end of another wonderful topic, which is machines. And today being the last lesson under the topic machines, I'll take the advantage to give a little summary of what we have done so far under machines. First of all, machine is a device that makes work easier or faster. Examples of machines, you can name them: washing machine, gears, wheel and axles, screw and pulleys. Both compound and simple machines. Now we also have a lever, which is a simple machine that consists of a rigid bar which turns freely about a fixed point. Now machines, simple machines, we have classes, which is the first class levers, the second and the third class levers. So don't forget, we can give examples. And we also said that work is said to be done when a force moves a body through a distance in the direction of the force. We also talked about the energy, and we said that energy is the ability to do work. We also talked about power, and power under work under machines is defined as the rate of doing work. And last but not least, we talked about the compound or complex machines. An example is the car, the tractors, and the rest that you can name. This is where time will permit us. And I'll end here with my lesson. Continue to learn hard. Until we meet again for another wonderful topic, stay blessed and bye-bye.